Hey there everybody, and welcome to another lesson on angles. Today we're going to combine everything that we've already been learning about so far in this unit and use it to solve a bunch of problems. So our I can statement for today is I can use angle relationships to solve for missing angles. So now when we're solving for missing angles, what does that mean? We're just trying to find the measurement of angles, like maybe when like it's marked with a B or an X or something and we don't know what they are, that's what it means to solve for a missing angle. And how are we going to do that? Might as well make a little note here. We're going to do it using equations. So we're going to be making our own equations and using those to solve for those missing angles. Okay, so quick review in our warm-up. Define the following. What are adjacent angles? Those are angles. I'm just going to use my little symbol for angle and then with an S after it for angles. Angles that are right next to each other. Right next to each other. That's in my way, so I'll go down here. In other words, they have to share a side. So adjacent angles always share one side. Okay, what about vertical angles? Those are angles that are opposite from each other, like across from each other, with a set of intersecting lines. In a set of intersecting lines. Okay, now just a quick picture. That's where you have the big X, or you could think of it as two V's with V standing for vertical. And your vertical angles would be like here and here. Or you could think of them as here and here. And vertical angles are always congruent, so those will have the same measure. Okay, going on to complementary angles. What are those? Those are angles that add to 90 degrees. They add up to 90. Supplementary, similar, except 180. So they're angles that add up to 180 degrees. All right, now what about a linear pair? That's the same thing as supplementary. Those are two angles that come together and form a line. See the word line in linear, if you take away the A and the R. But we can just say they're the same as supplementary, because when they come together to form a line, that means they add up to 180 degrees. So I'll also say form a line. Okie dokie, let's go on to some examples. So down here it says, we can use angle relationships and equations to find missing information in a diagram of angles. Okay, so example 1, name the most specific relationship between angles, and then write an equation that relates the angles, and then solve for x. Okay, wait, that's a lot going on. So first we have to name it. Step 1, name it. Step 2, equation. I'll just write EQ. And then step 3, solve. All right, so let's see if we can do that. Now we have this angle right here, and we have this angle right here. There's another angle right here, but we can ignore it because they don't have anything written there, so they don't want us to look at that. It doesn't matter. If you want to even just kind of disregard this line, you totally can. So what do you know about these two angles? Let's see, do they share a side? Yeah, they're sharing a side, so they are definitely adjacent. What about, are they going to add up to form either 90 or 100 degrees? I can't say that, or 180 degrees. Yeah, you see how they're both coming together to form a line? So they're going to add up to 180 degrees. In other words, they are supplementary. And another way to say that would be linear pair. So the best answers here, you could write adjacent, but you also need to include one of the other labels, such as supplementary or linear pair. Again, these two, they pretty much mean the same thing, so both of them are fine. Why is adjacent not enough? Well, it says the most specific relationship. And adjacent just means next to each other. It doesn't mean that they come together to form a line. So while adjacent is correct, it's not really complete. So definitely make sure you have either supplementary or linear pair in here. So that's the first thing, that's the name. Now let's go on to the equation. So we were talking about supplementary and linear pairs. They add up to be how many degrees? 180 degrees, because there's 180 degrees in the line. So if you had this angle that starts here and goes all the way to there, that would be 180 degrees. So basically this angle plus this angle is going to equal 180 degrees. So what do we call this angle? Let's call it 3x plus 18. Let's just write that down. Okay, so we got that one taken care of. Now we need to add it to this. So I'm going to say plus 93. And what is it going to equal? Well, the whole thing, like we've been saying, is going to equal 180 degrees. So we've got it like that, and then we just have to solve our equation. So let's see, this was step 1 here, this was step 2, that's our equation. Now step 3 is to solve it. So I'm going to grab my calculator, just make it a little easier. A good first step in this equation to solve it would be to combine the like terms. And right now I'm seeing 18 and 93. Those are just both regular old numbers. In other words, they're both constants. So let's combine those first. 18 plus, whoops, I keep hitting the wrong button here. Let me try again. 18 plus 93 equals 111. Okay, so I'm going to bring down my 3x, and then I'm going to combine those to be 111, and it still equals 180. Now let's subtract our 111 from both sides to get the 3x by itself. We're going to be left with 3x equals, let's see, what is this? 180 minus 111. I missed a 1 there. Let me try that again. 180 minus 111. 69 is the answer there. And then we're just going to divide by 3, and you're going to be left with whatever x is equal to. 69 divided by 3 is going to be 23. Okay, so that was step 3 we have solved. I'll put a little 3 here. And our final answer is x equals 23. Now, does that mean that this angle measures 23 degrees? No, it doesn't. That can be kind of the confusing part. It means that x equals 23. So if you plug 23 in for this x, multiply it by 3, add 18, then you would know what this angle is equal to. I want you to know that 23 is not the measure of the angle. So you don't need to put a little degree sign here because that's not the measure of the angle. Another thing to know is it is possible for that x to be a negative number because it's not the measure of the angle. As long as when you plug it back in, it forms something positive, because there are no negative angles. They're all positive. But it is possible for the x, just the x by itself, to be negative. All right, let's go ahead and do another example. Okie dokie, what is the angle relationship going on here? Are they adjacent? Are they vertical? Are they complementary, supplementary, linear pair? What do you think? Well, I see these two V's here. There's a V and there's a V. You've got these intersecting lines, and they're across from each other too. So you know that these are vertical angles. This one and this one, they're vertical. So for number 1, I'm going to write vertical. Okay, for number 2, let's make an equation. So we know that vertical angles are what? They are equal to each other, right? So we know that this angle measures the same as this angle. That means we can say that this right here is equal to this right here. So let's do that. We're going to say that 2 plus 3x equals 62. Just like that. Because we know the angles are congruent, we can set them equal to each other. Once we have like this, we can just solve. So let's get the 2 away from there by subtracting. We're going to be left with 3x equals 60. And once you have that, you're going to divide by 3 on both sides, and you'll just be left with x equals 20. And that was your step 3, which is to find the solution for x. All right, so in this first one, they added up to 180, and we used that in our equation. In the second one, we knew they were equal, and we used that in our equation. Let's see what we have in our next example. Example C. So we have this angle here. It says 6x plus 2. I'm going to make this a little bigger. And then we have this angle here that says 40. So we have this angle and this angle. Now, what about these two angles? They're adjacent, right? That's not really a complete answer, though. What else is going on? Well, we know that this angle here is a right angle because we see that. So this angle here, considering it's built on a straight line, we know that the other side of it is also a right angle. So that means that this angle plus this angle together come together to form a right angle right here. This right angle, right? So what does that mean? It means they are complementary. And that's what we want to write. You could write adjacent also, but make sure you get complementary in there. So that's the answer for part 1. For part 2, okay, let's think about what complementary means. It means that they add up to equal 90 degrees. Okay, so that means that this right here plus this right here, if you add them together, should equal 90 degrees. Okay, so let's use that to make an equation. 6x plus 2 plus 40 equals 90. All right, and now all we do is solve. Let's combine our like terms. We've got some constants here, the 2 and the 40. So I'll bring down the 6x, and then I'll add the 2 plus 40, which gets to be 42, and that equals 90. Now let's keep solving by subtracting 42 from both sides. We're going to get 6x equals 48, and then divide by your 6, and you'll be left with x equals 8. And that's your step 3, solving for x. Okay, we got one more example here, and then we're going to do a couple problems from your assignment. On part D, it says, what name would we give for this one? Well, let's see there. We've got that angle, we've got that angle, and then we've got this giant angle here. So they're all next to each other. Let's definitely say adjacent. Are they complementary? No, that doesn't form 90 degrees. Are they supplementary? No, it doesn't form a line. Are they vertical? No. Are they a linear pair? No. Oh, you know what? Adjacent is the best name you can give this, so that's what we're going to give it. Just stick with adjacent. Now let's look at it and think about what we know and make an equation. Well, we've got this angle here, and this angle here, and then this angle all the way around here. So it forms a whole circle. And how many degrees are in a circle? 360, right? So this angle plus this angle plus this angle have to equal 360. Let's use that knowledge to make an equation. So this angle plus this angle plus this angle. We're going to do x minus 24. There's the first angle. Add 29 to it. There's the second angle. Now add 296 to it. There's the third angle. And what does it equal? It equals the whole circle, which is 360 degrees. All right, now you've got your equation. Oops, that went off screen. Now you've got your equation, just have to solve it. So let's combine some like terms. You have minus 24, make sure you think of that as a negative number. You have 29, and you have 296. So let's just combine those. I'm going to grab my calculator, and let's see here. Negative 24 plus 29 plus 296 is going to equal 301. So you have x, it was a positive 301, so I'll put plus 301, equals 360. And then if you subtract 301 from both sides, you're just going to find that x is equal to 59. All right, so there's another thing that I skipped over. Hang on, this was part 3, this is part 1, and this is part 2. There we go. There was one little line that I skipped over, you may have noticed. It says, thought question. How could we make sure we have the right value for x for the problems above? So for both of these, you kind of wind up with an x, and you're like, well, gee whiz, I hope that was right. Do you know what I mean? Let's take this one for example. How could we just tell, how could we prove to ourselves that x equals 20 is actually correct? Pretend you're taking maybe like the RISE test or something, and you have a few minutes left at the end and you want to double check. Well, here's how you would do it. You know that these two are equal to each other. So this expression really needs to equal 62, right? So if you take that 20 and plug it in for x, then you should get 62. Let's see if it works. So you have 2 plus 3x, except we're going to take out the x and we're going to put 20 in. So I'm going to say 2 plus 3, oh, whoops, I messed up. 2 plus 3 times 20. Okay, now let's solve this. That is the same thing as 2 plus 60, and 2 plus 60 equals 62. And that's the number we were looking for. So you would know that you're right on this one. Same idea here. You could plug it in for x. So 3 times x, in this case we're going to plug in 23. 3 times 23 plus 18 plus 93. And all of that should equal 180. And if you do the math on that and it works out and it does equal 180, then you know you did it right. Okay, so now a couple examples from the assignment. Here's your assignment. At the top it says, name the angle relationship. So you might use any one of these words. Oh, sorry, this is one. Adjacent and adds to 360. That would be like one angle relationship. Complementary or supplementary. So there's 4 different choices. Vertical, adjacent, and that's to 360. You could just write an A if you want. It's okay with me. Complementary or supplementary. All right. And then you find the value of x. Make sure you're writing an equation, okay? So let's look at number 4 together. How about these angles? What are they? What of these 4 relationships applies to number 4? They're not vertical. They're not complementary. They're not supplementary. They are adjacent and they do add to 360. So I'm just going to write a big A. And now I'm going to write an equation. So like we just said, they're going to add up to 360. So 298 plus 27, and then add together this minus 14 plus x. It should all equal 360. I'm actually going to start with this one. So negative 14 plus x plus 27 plus 298 equals 360. And now you're just going to combine your like terms. So where are your constants? You have negative 14, you have 27, you have 298. We're going to combine those together. Here's my calculator. Negative 14 plus 27 plus 298. Looks like it's positive 311, so I'll just write 311, and then I still have this plus x to bring down, so don't forget him. Plus x equals 360. We're going to subtract that 311 from both sides, and you'll get x equals, whoops, I did that wrong. 360 minus 311 is going to equal 49. So you know that your x equals 49 there. Let's look at a different example. What if we went to number 8? Excuse me, number 18. I have the one kind of covered up there. So what's that angle relationship in number 18? Well, you have these 2 intersecting lines. So you can kind of see that V formation across from each other. These lines over here, they don't matter. You can scribble them out or not, but I want to make sure that you're focusing on these intersecting lines, okay? So these are vertical angles, which means that they are what to each other? They are congruent. Yes, they're going to have the same measure as each other. So this is going to equal this, and that's exactly what we're going to write in our equation. So this being 3x plus 2 equals this, which is 65. So you just write it like that, and then you solve. Let's do it. Let's subtract the 2 from both sides. You're going to get 3x equals 63, and then x equals, well, I don't know. What is 63 divided by 3? Let's find out. 21. X equals 21, and you're done. So that's your assignment. Thank you for watching. Let me know if you have any questions, and I'll see you next time. Bye.